Hello, welcome back. Again, my name is Greg Perugini, and today we'll be doing lab number 4. Lab number 4 is ramp physics. So, what is entailed with ramp physics? It is kinematics in 2 dimensions. We have a ramp, and we have an angle for that ramp. And when I'm rolling something down the ramp, we have an acceleration due to gravity. Now, if it was going straight up and down, it would just be g equals 9.8 meters per second squared. But it isn't. It is going down a ramp, much like Galileo did it, and that ramp will dilute the angle by sine of the angle, so you have g times sine of the angle. That is how fast it would be going down this ramp. However, that's in a theoretical world. In reality, we have friction that is holding it back, slowing it down. We can calculate how much it's slowing it down by knowing that frictional force is equal to ma, is equal to, for friction, in this case, rolling coefficient times the normal force. The normal is diluted by cosine of the angle. So what we find is it's not just g for the normal force, but g times cosine. So the acceleration that is, in a sense, decelerating our ball from the roll down this ramp, we could figure out the acceleration of the deceleration as the coefficient of rolling friction times g times cosine of the angle. So let's go now to take a look at what equipment we'll be using to do this. We're going to use this ramp, and this ramp is assembled. We're using only one of the small spacers. We assemble the ramp with 2 of the hangers, 2 of the metal hanger hooks, I should call them, and we have our ramp, and we've assembled the equipment using the dome base with the mast. So, one of the things, as you saw up on the board, is that we had to calculate the angle. Now, there's a couple of ways I could calculate that angle. Number one is I could try to do it using a protractor. And you could do that, but you should probably verify that by measuring the length of the ramp and the height of the ramp. So what we're going to do, and we'll get back to what you do with those 2 measurements, is that you're going to roll the ball down the ramp. I want you to do at least 5 trials. And you have a distance that this is going down the ramp. Measure the distance that it's going down the ramp. Okay? So let's go back to the board. So as I said, I can either use a protractor to measure this angle, or if I know how high the ramp is and how long the ramp is, I can calculate the angle there. So you probably want to do it both ways and verify that. Once we have the angle, we need to calculate what the coefficient of friction is. So our actual acceleration should be the difference between these two. If I do 5 trials, I know my velocity final. I can calculate my velocity final going down the ramp if I knew the acceleration in the time. But what I probably want to do is, if I know the ramp distance using x as displacement, I can use this kinematic equation knowing that my velocity initial is what? Well, if I'm starting from rest when I'm rolling the ball down, it's 0. My change of x is the length of the ramp. Timing. I would use my stopwatch over 5 trials to get the acceleration. We'll call this experimental acceleration. Once I have the experimental acceleration, or we can get the experimental acceleration here by timing it and knowing the length of the ramp. That experimental acceleration I'll write it with the sign first. That experimental acceleration using g and using the angle would allow you to calculate the rolling friction. That's what you need to do for this lab. Calculate the rolling friction for your particular ramp. The rolling friction, more specifically, of this type of plastic with the marble. And that's lab number 4.